Hello guys, around 2 years ago I designed this library to perform the data share between the two cores of the STM32H7xx. It's the board that I have here. But this library was very simplistic, and I didn't like the implementation because it didn't have any protection against read or writing, any lock protection, atomic protection. Also, I didn't like the definitions, so I decided to rewrite from scratch this library. Uh, and I want to keep in mind while I rewrite this library that I want to make it also yet simplistic, but I don't want to use low-level stuff to perform atomic operations. The only core-specific stuff will be the run address and its size, and I'll try to use the standard C library. I have already created a project here where I created here a header and a source file, uh, and we use them as skeletons for our implementation. I have also included here in the two main files for the two cores. I have included the header, and in the infinite loop I defined some buffers here, and I will call these libraries, these functions here. I'll leave it commented for now, and we will do the implementation now. So this C source file, let's first define a struct. So struct, this structure is for the data shared between the two cores. So let's call it shared data, only shared, okay. It will have two logs because I will have two buffers. One of the buffers, the CM7 core will write and the CM4 will read, and the other buffer is the CM7 the core with who will read the buffer. So let's first define the logs. So let's use bool here. So log 1 and log 2. Let's define the buffers. I think the buffers can be, let's see, it can be ints. So buffer 1 with a size, let's define the size here, if not f, buff shared size. Let's define it, okay. I'm sorry. Okay. Define then buff shared size equal at least 32 items, and then okay, let's write it here. It will be buff shared size 1, and I say buffer 2 also the same size. We can also define the a variable to define the size or the number of items that are available in each buffer. So let's define as unsigned int buffer one size and buffer two size. Okay. Here in the core share init, this is the function that will initialize our variables. I want to have a variable here. I think it will be called shared library. It will be a global library. Sorry, a global variable. So struct shared. Let's define this as shared data. But I want it to be in the RAM D3, so we'd have to define it in our linker script. So let's open our linker script. We have to open and define the section for each of the linker scripts of each core. So let's open the STM3. We have here RAM D3 length 64K. So let's define the 64K as a variable here. Sorry, as a label. RAM D3 size equal to 64K. I will substitute it here. It will be RAM D3 size, and down here we can define a section. Let's define what about dot shared column. Let's open it and close. This will be in RAM D3, and let's do this then. Okay. Okay, let's define as star dot shared. Okay, and I think it would be good to have some asserts to verify that our buffers don't overflow our RAM size. So let's start. Let's define here a start shared dot and a and shared dot. So let's define here assert. I think it is and shared minus start shared. It should be less or equal than RAM D3 size, and it should have a message, I think. Let's call it RAM D3 too big. Let's try to compile this. I have no idea if this will work. Okay, I think it worked. Let's see if we can call our if we can define our variable here. Let's call it an attribute section. That's the name of section. Data is it shared? I don't remember. Okay, let's see it here. Let's see if this section is defined now. Okay, different D3. Okay, data shared. Okay. Okay, so let's also define the same in the link scripts for the CM4 core. So let's define this. Let's copy this and paste it here. I think here is good. Okay. So when we try to compile this, it should be give us an error. But first, let's also define the memory for RAM D3. And this and paste it here. And also this label young, and let's paste it here. Okay, now we can keep going. In one of the cores we should call our core init function. Core init, core share init, sorry. Okay, it compiled with no error. Let's keep going. So in this, so in core share init we should clear our locks, but we shouldn't only do this like lock 1 equals 0 or lock 2 equals 0. I think it should be atomic. So we can also define this variable as atomic. And in the C standard library, we have a header called standard atomic. And this header has some functions to clear the atomic flags. So what we can do here is called atomic flag clear, and then we have to pass the address of our lock. So let's call share data dot lock1, and then it will clear for us. So yank this line and also do the same for lock2. Let's see if this compiles, and it compiles. Okay. Let's see if there is any difference here in round 3. Okay, not yet. Okay, maybe the compile is optimizing it out, but let's see. One of the things we can do here is, since we have this atomic bow, we can replace this with a definition of that is in this header. Let's open it here. And we can define atomic bow. Okay, so let's replace this and define atomic bow. Okay, let's try to compile again and see if this works. Let's also initialize the buffers to 0. Buffer 1, sorry, the size is to 0. And buffer 2 size also 0. Okay. Sorry, I think I forgot to define here shared data dot. Let's try again. Okay, it works. Now we can define our first function. Let's go to the main file of the STM7. Let's see. Let's define the first function. Put to STM4. Let's uncomment this. And let's see here. It will return a status and put to M4. What it will receive as arguments? I think it will receive a buffer, a constant buffer pointing to const value. So say const int and const restrict buffer and a size. So I think it can be const const unsigned int size. So it is defined here. Let's also copy this to the header file. Let's go back there and now we can define this function. So the first thing I believe we should do is verify whether the lock is taken. So one thing we can do that is provided in the standard atomic library is we can do atomic flag test and set, and then we pass the address of our lock, shared data, in this case lock 1. If the lock is already taken, let's return -1. If it's not taken, then we'll do the copy of the buffer. So the first thing we have to verify then is if the size is less or equal the size available of the buffer 1. So okay, so let's define the shared data dot buffer 1 size, and then we're going to question, is it less or equal buff shared size? Then it will receive size. Otherwise, sorry, it's a question here, to receive size. Otherwise, it will receive buff shared size. So in this case, we are limiting our buffer size. So we don't write past it. Is that right? Yeah, I believe it is. So let's do a for loop here and copy the data. Is less than shared data for 1 size I++, and then shared data dot buffer 1 y is equal to buffer I. Okay, so in this case I think we can unlock now our lock. So atomic flag clear, we pass the address of our lock. So share data dot lock 1. What about we return the size that was counted? So that the CM7 core can know the size that was passed, because the CM7 can try to pass, let's say, 33 items, 33 values, but only 32 are available. So it should know how many items it passed. So let's return the shared data buffer size. Okay, buffer one size. Let's try to compile this. And it seems that it worked. So let's verify it here. Yeah, it seems that it worked. Let's verify here the memory. Okay, round D3 should have something, but it is not here. Let's see in Flash. It's not here also. Where is it? Data. Okay. I'll keep going. I'll try to fix this at the end. Let's perform the get from M4 now. So when we're trying to get from the M4 core, what should we do? We should pass we should pass the destined buffer, also its size. Okay, let's also pass its size. So let's say 5 also here. Okay, let's go back to the source file. It will also return a status get from M4. Okay, this is not a constant, it's a constant pointer to variable values. Okay, so some points it's const restrict buffer size is const. Maybe we can use it as a variable. So let's not define as a constant. Assign int size. Okay. Let's define this in the header file as well. And let's go back to the source file. So we have to verify whether the lock is taken. This is not the lock 1 now, it's the lock 2. So let's verify if the lock 2 is taken. Or let's see if the CM4 core is writing, sorry. So atomic flag doesn't set. Let's pass also the address shared log2. If it is taken, let's return -1. Okay. Then let's define this and return 0. Okay, it is compiling. Okay, let's see. So the log's taken. We have to verify whether the size is greater than the available. So if size secure buffer. Let's create the buffer2 size. Size then is equal to buffer2 size. Okay. And then we can copy now for unsigned int I equal 0, I less than size I plus plus. Let's do the following. And then we will copy from the buffer2. So share data buffer2. Okay. Okay. Let's now. So we copied. Since we copied it, let's say we don't have the buffer. We don't have data in the buffer anymore. So share data buffer2 size equals 0. Okay, and then let's clear the log. So shared data dot log2, and let's return the size. Let's try to compile this. Okay, so here it is, and now we can, if you want, the user wants, we can define here unsigned int red items in number of red items. Define as 0 for now, and then we can test how many items were red. So in red items equals this, and then the user can verify, and if any red items not equal, let's say less than 5 for example, and then we can do following as a continue, something like this. Let's try to compile this. So I defined this wrong again, and signed. Okay, let's try to compile this. Now let's try to verify this. I still don't believe that this is wrong. Why is that? Let's open again our linker script to see if I defined it right. Round 3, so here it's right. It should be here. Let's increase the size, let's say instead of 32, let's say 100 to 1000, and let's compile again. Then okay, now here it is. So it was right from the beginning. I'm sorry. Okay, so since this video is already too long, I will not show the implementation for the other course, but I will do it, and I will update the GitHub repository with the corrected code. So this showing again, we have to define the section here, defined in rand3. Also have to define the same region, the same section in the linker script for the CM4 core. We have in one of the cores, we have to call this core share init function, and then we can already do the reading and writing. One other thing that I would like to show is the following. I want to show the disassembly of these functions. I will open them here. So let's go to debug and open the .list file. And let's show them side by side. And let's look for this function. So it's already here. Let's look for the put2m4. We can see here in put2m4 the disassembly that we have now some data memory barriers here, since we defined our variables, our logs as atomic, and also we have here some load exclusive and store exclusive. So this is from using these functions, atomic flag clear and atomic flag test and set. So we have here successfully implemented the lock with atomic variables, so we have now some more safety. For the GitHub repository, then I will try to comment this code so that you can understand it better. So for today, that's it. Thank you guys again. Until the next video.